Hello everyone. Today I'm going to share with you some of the important topics that have been issued lately, which is cybersecurity, measures and protection and controls the smart power grid, which is one of intelligent electronic devices. In this presentation we are going through introduction about smart grid and some of the threats, and then real life cyber attack and how could it be prevented, and finally the conclusion and the benefits comes out of it. The electric power grids and power system are critical infrastructure parts of our modern society and obtained by high demands on reliability and stability. Our current electric grid was conceived more than 100 years ago, when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where the electricity and information can be exchanged between the utility and its customers. It's a developing network of communication, control, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and more greener. The power being used right now was generated less than a second ago many miles away. At each instant, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This is greater insight and control reduces outages and lowers the needs of peak power. In control rooms across the grid, engineers will be able to more predictably manage electricity production. The distribution system routes power from the utility to residential and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any breaks in this system caused by storms, bad weather, or sudden changes in electricity demands can lead to outages. The smart grid's distribution intelligence counters these energy fluctuations and outages by automatically identifying problems and rerouting and restoring power delivery. Utilities can further use distribution intelligence to protect in electricity usage with the cooperation of their customers, leading to lower production costs. The smart grid involves incorporating modern computing technology into the electric grid in order to make it more efficient. Such technologies include hardware probes out in the fields, our wireless network technologies so that anyone can monitor the grid in real time from any other location. The workers in the smart grid lab made probes to go out in the field area networks for clients such as California and Hawaii. They monitored the networks with custom web applications they built, and also popular packet reading software such as Wireshark. There are also some threats for these smart grids. Smart grids are mostly online to enable the communication with the customer and to cover nature, and this makes them vulnerable to cyber attacks, like malware, like the denial of service attack, the individual attacks, and synchronization attacks. These attacks leads to service distribution, electricity theft, and also sometimes information theft. Example of a cyber attack which took place on December 23rd of 2015. It's the first known cyber attack on the power grid. More than 30 substations were switched off and about 230,000 people were left without electricity for a period of 6 hours. Three distribution companies' information systems have been compromised by the hackers, which are later assumed to be the Russians. They hacked the SCADA, the Supervisory Control and Data Acquisition, which is a type of industry control system, and it's commonly used in the power stations. The hackers hacked the SCADA to switch off the power supply. How exactly they hacked the system? It all began with the phishing emails to gather the information of the employees at the distribution companies, and by using those emails, they gather information like the passwords. Then deployed malicious softwares into the systems and took over the SCADA components. disable the IT components and thus stop the power supply. Then they use also the denial of service attack on the call centers and thus denying the information to the all users. This is more detailed how the process worked. It starts as IT preparation, as target selection and malware development and testing, to hunting and gathering like control system network and host mapping, then sequence pre-work, upload additional attack modules like kill disk, and then attack launch, and then spear phishing like establish foothold, and then ICS preparation, and then attack position, and then target response as connection server, manual mode and control inhabit, cyber assessed restoration, electric system restoration, system hardening. Now let's discuss how the attack could have been prevented. The attacks on industrial control system are not instantaneous, but it takes several months for the attack to occur, which gives many opportunities to detect or distribute the attack. There are very different ways by which the attack could have been prevented. First one is the network security monitoring. Its analysis and escalation of indication and warning to detect and respond to intrusions. And the second one is behavior analytics, which is defined as a tool to detect patterns of data transmission in the networks that are out of the norm. The third one is the SCADA aware firewall system. By implementing firewalls which prevent unauthorized remote access of the SCADA. And the finally email security gateway, which monitors emails being sent to an organization for unwanted content and prevents these messages from being delivered. Now let us discuss some other security measures that can be used to protect the smart grids from cyber attacks. So the first one is the data security. The provider or the cybersecurity expert should implement security requirements in order to protect the information. Smart code information system procedures for handling and storage of information should be established to protect this information from unauthorized disclosure. Second, the account management. The provider should establish and maintain system groups and account users on the smart code information system. The logical access control, which the provider should enforce logical access and create information system and security parameters, which includes rules that grant or deny access to known users based on their rules. And then the key remote access, which the provider should establish an applicable smart grid information system. Then the network segregation. The provider should establish and maintain a segregated network for a smart information system, where the infrastructure of the process control should be divided into multiple zones with different functions and protection requirements. And finally, the secure network communication, where the provider should establish and maintain secure communication across a segregated network. Smart grid is a great technology, but it's vulnerable, so certain threats and attacks. But by taking precautions and proper security measures, these attacks can be prevented. There are some references used to collect that kind of information. If there is any question, let me know. Thank you.